Quantum communication is about to change the way we send and protect information forever. But why is quantum communication so powerful? The answer lies in the strange, mind-boggling world of quantum mechanics, a world where particles are mysteriously linked across vast distances. Stick around to find out how this weirdness could be the key to a completely secure, unbreakable internet. Picture this: sending information without physically moving it. Sounds like magic, right? But it's quantum teleportation, and it's real. Recently, a groundbreaking experiment showed how quantum entanglement, a phenomenon where particles are instantly connected no matter the distance, can be used to teleport information securely. But what exactly is quantum teleportation? Well, it's not teleporting people or objects like you might see in science fiction movies. It's the ability to transfer the state of a particle from one place to another without physically moving the particle itself. You might be thinking, how is that even possible? The answer lies in a very strange quantum phenomenon called quantum entanglement. A concept that's weird and not something we see in our day-to-day life, but incredibly powerful. So, what is quantum entanglement? Imagine you have two quantum particles like photons that become entangled. This means their states are linked. Whatever happens to one particle instantly affects the other, no matter how far apart they are. It's as if they share a mysterious connection that transcends space and time. Sounds mind-bending, doesn't it? Well, quantum entanglement is one of the most puzzling and powerful phenomena in quantum mechanics. But here's where it gets even more interesting. To help wrap your mind around it, let's use a classic analogy using Schrödinger's cat. Imagine you have a box that contains a cat and a bomb that are entangled. If the bomb explodes, the cat dies. If the bomb doesn't explode, the cat stays alive. Now when you measure the bomb's state, you will immediately know the cat's state. If you open the box and find the bomb exploded, you know the cat is dead. And if the bomb didn't explode, the cat is alive. So the cat and the bomb are entangled. The twist here is that even if the bomb and cat are separated by vast distances, once you measure one, the state of the other is instantaneously determined. This is quantum entanglement at work. But you might be wondering, how do scientists actually create these entangled particles? Well, it's not as simple as just wishing them into existence. Typically, scientists create entangled particles using special processes like spontaneous parametric down conversion. In this process, a high-energy photon, like light, hits a special crystal, causing the photon to split into two lower-energy photons that are entangled with each other. Once the entangled particles are created, scientists separate them by sending them to distant locations, sometimes miles or even thousands of miles apart. They use sophisticated optical fibers or satellites to send these particles without them losing their entanglement. Even though the particles are now separated by great distances, their entangled connection remains intact. This is the magic of quantum entanglement. Now let's bring it back to quantum teleportation. What makes quantum teleportation possible is the power of entanglement. In quantum teleportation, information is transferred between two distant locations by entangling particles and using the instantaneous link between them. In the case of quantum teleportation, scientists don't actually send the particle itself over long distances. Instead, they send information about the state of the particle through an entangled system. Imagine Alice wants to send a quantum state to Bob. First, they create a pair of entangled particles. One stays with Alice, and the other is sent to Bob. These particles are linked, so whatever happens to Alice's instantly affects Bob's. Alice measures her particle, then sends Bob just 2 bits of information about her measurement. With that, Bob can recreate Alice's quantum state, teleporting the information across space without moving a single particle. So, the state of Alice's particle is teleported to Bob's particle without the actual particle ever physically moving across space. Quantum teleportation isn't just a theoretical concept. In 2017, China's scientists made history by using quantum entanglement to send information over 1,200 kilometers via a satellite-based quantum communication network. This was the first time such a demonstration of quantum teleportation was successfully carried out in space. And, in December 2024, Professor Prem Kumar and his team at Northwestern University have taken it a step further by achieving quantum teleportation over fiber optic cables, the same cables that already carry regular internet traffic. This means quantum teleportation could eventually be integrated into our existing communication networks, unlocking new possibilities for secure and fast data transmission. So, how does this relate to secure communication? In today's digital world, our data is often transmitted over the internet, but there's a major flaw in the current system's security risks. Data can be hacked or intercepted by malicious actors, even if it's encrypted. This is where quantum entanglement and quantum teleportation can change everything. In classical encryption methods, encryption keys are used to protect data during transmission. But there's a major problem. If someone intercepts the encryption key, they can easily decrypt the data. This is a huge risk in modern communication systems. On the other hand, quantum communication is extremely sensitive to external disturbances. Unlike classical systems, where information can be intercepted or copied without altering the message, quantum systems don't allow this. Why? Because quantum states are fragile. The very act of measuring or interacting with a quantum state, like an electron or photon, changes it. This is what makes quantum communication so special and secure. With quantum communication, quantum key distribution, QKD, comes into play. In QKD, the quantum entanglement ensures that any attempt to eavesdrop on the transmission will disturb the quantum state, making it immediately noticeable to the sender. So, if someone tries to hack into a quantum-secured communication, they will be caught. In other words, quantum encryption guarantees that your data is unbreakable, no matter how powerful the hacker or the computer. Let's be clear. Quantum communication holds incredible promise, but there are significant challenges ahead. One of the biggest hurdles is the fragility of quantum entanglement. Quantum states are highly sensitive, and even small disruptions like temperature changes or vibrations can break the entanglement. This makes long-distance communication difficult. To address this, researchers are developing quantum repeaters to amplify entanglement signals, extending the reach of quantum communication networks. Another challenge is the cost and complexity of quantum technology. Building these networks requires specialized equipment, and scaling them up to a global level is no easy feat. However, breakthroughs like the work from Northwestern University are helping. They've shown that quantum teleportation can work over existing fiber optic cables, which could dramatically reduce the cost and infrastructure needed for a quantum-secure internet. Thanks to advances like these, the dream of a quantum internet is becoming a reality. Kumar's team is pushing the limits even further. They plan to extend their experiments to longer distances and explore entanglement swapping, which will help distribute quantum information across entire networks. They're also testing this on real-world underground optical cables. So, the quantum revolution is already in motion. Looking ahead, a fully operational quantum internet is still a few years away. But innovations like quantum repeaters and hybrid networks, combining quantum and classical systems, are bringing us closer. With these breakthroughs, we could soon have a quantum-secure internet that makes hacking a thing of the past. Imagine a world where your data is safe, unbreakable, and instantaneous. So, whether it's for secure government communications, business transactions, or even personal data, quantum teleportation is leading the way to a new era where hacking and cyber threats are things of the past. If you're as excited about the quantum future as we are, be sure to like, subscribe, and hit the bell icon so you never miss an update on the world of quantum technology.